Today we talk about the chapter 3, differentiation, part B. It's applications of the rule of differentiation. Or you can say differentiation or derivative. We are going to apply those rules we learned in part A to the real world questions, like solve the problem in the economics or in the social science or business. Part A, we learn our rules, which is covered in the textbook section, chapter 3, section 1, 2, 3, 3.1, 3.2, 3.3. Now today we are going to learn its application part. In chapter 3, we learn section 3.4, 3.5, 3.6, and 3.7. 3.4, the title is a marginal function in economics. Marginal function in economics. First question, suppose the total cost in dollars incurred each week by Polario for manufacturing X refrigerators is given by the total cost function, C of X equal 9,000 is the fixed cost plus variable costs in terms of X, 300X minus 0.3X squared. This X is X refrigerators. How many units? How many refrigerators? Add the fixed cost. A, what is the actual cost incurred for manufacturing the 241st refrigerator? So we do the cost of 240. Total cost if manufacture 241 refrigerators. Total 241 refrigerators, total cost, minus the total cost for manufacture 240 refrigerators. If the two subtraction is going to be the actual cost for manufacturing the 241st refrigerator. Only one at 241st. So we do total cost for 241 refrigerators cost minus the previous 240 refrigerators cost. That is going to be the only one refrigerator manufactured at 241 refrigerator. So do the two subtractions. So X use 241, plug into this total cost. This is a total cost for 241. X use 241, plug in. So it's 9,000 plus 300 times X replaced by 241 minus 0.3 times X replaced by 241 square minus and 240 total cost is X replaced to 240. So 300 minus, put in the parentheses, 9,000 plus 300, X replaced by 240 minus 0.3, 240 squared. So then you remove this bracket, minus 900, this plus change to minus, this minus change to plus, Then 9,000 minus 9,000, subtraction is 0. Then this term with this term, common factor 300 factor out. Put in the parentheses 241 minus 240. You can distribute it in, that is this term. Distribute it in minus this term. And now you factor out, 300 factor out. And this term with this term, the two term, common factor 0.3 factor out. And here's plus, put first. 240 square, put first. Then here's minus, put second. Minus 241 square. If you distribute it in, that's this term. Minus this distributive in, that's this term. Then this 241 minus 240, it's 1. This subtraction, it's 1. And this add 0.3, put in. And this use the formula. The formula is a squared minus b squared equal to a minus b times a plus b. So a is 240 minus 241 times 240 add 241. Use the formula. 240 minus 241. 240 add 241. Then simplify. 300 times 1 is 300, and plus 0.3, 0.3. 240 minus 241 is a negative 1 times 240 add 241 is 481. 481. Now use calculator. You got 300 minus this time together, and use calculator, and you will find out and produce one refrigerator at 241 is $150.70. And put a dollar, put the units is in dollar. The next, find the rate of change of the total cost function with respect to the x when x equal 240. So that is the first derivative. Rate of the change is always the first derivative. So you take c function, take first derivative. C function, take c prime of x equals 9,000, take derivative is 0. 300x, take derivative is 300 minus 0.3 times 2, and x to the power 2 minus 1. So the 0.3 times 2 is 0.6x. So you got 300 minus 0.6x. That's the first derivative. The rate of the change is the first derivative, is the c prime of x. Then at x equal 240, so 240 plug into the x for the first derivative. 200x replaced by 240. 300 minus 0.6 times 240. 0.6 times 240 is 144. Subtract from 300, get 156. So when produce at the 240, the rate of the change of the total cost at 240 is $156 per unit. This with the previous one. This we call average change. The A we call actually we call average change. This one actually average change. Average change. This one we call rate of the change. Rate of the change is the first derivative. Average change is C is and the 241 minus 240, which is actually just equal 1. So it's actually this. This is average change. So 1 units. 1 units you produce at 241 refrigerator is $155.70, and use and this we call rate, instantaneous rate of the change. And this is average change. This instantaneous, this we call average rate, which is we learned in chapter, and this we call rate of the change. Also, we call instantaneous rate of change. That's we learn in chapter 2. This is the first derivative is instantaneous rate. And then this subtraction we call average rate of change. And then you see the two very close to each other. So, and because this one when the 2 points closer to each other, h approach to 0 is going to be this. So that's we learn in chapter 2. So, and then use over here, we can get actually cost and also the instantaneous rate of the change. It's first derivative. The two should be close to each other, very close to each other. So the next one, the actual cost incurred in producing an additional unit of a certain commodity, given that a plant is already at a certain level of operation, is called the marginal cost. Now, so what is the marginal cost function? Marginal cost is the actual cost incurred an additional 1 unit rate. 1 unit of a certain commodity we call marginal cost function. So this one, marginal cost, this is marginal cost, 1 unit, an additional unit. This we call marginal cost. Now, marginal cost function is the derivative, which is this one. Marginal cost function is the derivative of the corresponding total cost function, which is C prime of x. So marginal cost function is C function, total cost function. Take derivative is marginal cost function. So for A, with this we call marginal cost, and B we call marginal this C prime of x we call marginal cost function, which is the C function. Take this with total C of x we call total cost function, and the C prime of x, this one we call marginal cost function. And this one is a marginal cost. This one is marginal cost. This is actually cost. This one is actually cost. This one we call marginal cost. This is actual cost. And this is marginal cost at a certain time, at a certain level of operation. It's called marginal cost. So this one is marginal cost. And the first derivative is marginal cost function. So let's do the next second question. A subsidiary of electronics manufacturers a portable DVD player. Management determined that the daily total cost, this one is a total cost function, of producing this DVD players in dollars is given by C of x. This function is total cost function, where x stands for the number of DVD players produced. How many DVD players? So those three terms have x, and is a various cost. Add 6,000 is a fixed cost. add together is total cost. A, find marginal cost function. What is a marginal cost function? Is just rate of the change of total cost function. Is the first derivative of the total cost function. So it's C prime of x. C prime of x. So this function, total cost function, take derivative. You got 0.0002 times 3, get 0.0006 x, 3 minus 1, x squared, minus, still minus, 0.09 times 2 is 0.18 x, 2 minus 1 is to the power 1. 50x times take derivative is a 50. 6,000 take derivative is 0. So this is a marginal cost function. It's the first derivative of the total cost function. So then find out marginal cost. Marginal cost when x equal 100. So x is 100 DVD players. So you plug 100 into this C prime of x. So get C prime of 100. X replaced by 100. So get 0.006 times 100 squared minus 0.18 times 100, add 50. So this square is 100 take square is a 100 times 100. So after, so you will get 1, you got 1, 2, 3, 4 zeros. You can use calculator, or you can do by the hand, times 0.0006 and tying together. Here is 4 zeros, so you move decimal point 1, 2, 3, 4, and you got 6. So you got 6. Move decimal. Here is a square is 4 zeros, so you move this decimal point 1, 2, 3, 4, get 6. Minus 0.18 times 100. 100 has 2 zeros. So you move this decimal point 1, 2 and get 18 and plus 50. So it's 50, add 6, 56 minus 18, get 38. So put down the units. So answer is $38 per unit. Final answer, you need to put down the unit. You cannot just answer 38. You have to put units. It is $38 per units. Then next, find the average cost function C bar. So C bar means mean. Mean means average. So it's total cost divided by x units. That's each unit's cost function. So and divided. So you do this total cost function C of x divided by x. Total you make x units, and you got average cost function. So this 0.002 x cubed cancel x, remain x squared, and minus 0.09 x squared cancel x, remain x. 50x cancel x, get 50, plus 6,000 over x, get this. That's the average cost function. Then find the marginal average cost function. What is marginal? Marginal always this average is average cost function. Take first derivative, and you got marginal average cost function. So you do C average cost function C bar of x equal 0.02 x squared minus 0.09 x plus 50 plus. Change this 6,000 to x over x to exponential form. Move x up, become x to the power negative 1 times it. 6,000 times x to the power negative 1. So then you take first derivative. So get 0.002 times 2 is 0.004. x2 minus 1, get x to the power 1, minus 0.09 times 1 is 0.09. X to the power 1 minus 1 is x to the power 0 is 1. So is this take derivative is 0.09 minus plus 50 take derivative is 0 plus negative 1 times 6,000 is negative 6,000 x to the power. This minus 1 is a negative 1. Add negative 1 is negative 2. Then bring this x to the power negative 2 down to the denominator. Becomes 6,000 over x squared. Become this. Then figure out C prime. C bar prime. First derivative. This function take this first derivative at 100. At 100. So 100 plug in. Plug it into this. Plug it in. So 100 plug in. So is x replaced by 100 minus 0.01. That's 6,000 divided 100 squared. So this 2 0. So you move decimal point 1 2 position. Get 0.04 minus 0.09 minus 6,000 over 4 zeros. So this one divide 6,000 divided by 1, 1, 2, 3, 4. So it's 4 zeros. Point here, you move 1, 2, 3, 4 position, get 0.6. So get 0.6. So it's because 100 squared is 1, 0, 0, 0, 0, 4 zeros. So move decimal point from 6,000 from here to 1, 2, 3, 4. Get 0.6. Get 0.6. And this figure out is negative 0.65. That's the rate of the change. Then, which is for each one, each units. Then question 3. Suppose the relationship between the unit price P in dollars and the quantity demanded X of Acrosonic Model F loudspeaker system is given by the equation is P is price equals negative 0.03 X plus 6,000, and X is how many units? From 0 to 20,000 units. 20,000 speaker systems. Suppose the cost of producing X units of Acrosonic Model F loudspeaker is in dollars. Cost is C of X equal 200X plus $300,000. $300,000 is a fixed cost fee, and the variable cost is each X units of speakers times 200 is variable cost. Find out the revenue function. Revenue function is each unit is P dollar times total X units. So is revenue function is P is the price, selling unit, selling price. Each selling price is P dollars, and demand quantity demand is X units, which is you can sell out X units, and each unit sell P dollars. So P times X is revenue, is the money income, revenue, money income. So P times X. P dollar, P is what? P in terms of X is negative 0.03 X plus 600 times X units, demanded X units. So get revenue function. So distributive in is negative 0.03 X squared plus 600 times X. This is revenue function. And find out the marginal revenue function. Marginal is the first derivative. So R prime of X. So you take derivative. So the negative 0.03 times 2 is negative 0.06 x to the power 2 minus 1 is x to the power 1 plus 600 times 1 is 600. 1 minus 1 is x to the power 0 is 1. So this is a marginal first derivative, which is r prime of x. And compute r prime of 3,000 when the x is 3,000 speakers demanded. What is the revenue? So 3,000 plug it into this, get negative 0.06 times 3,000, add 600. So this time together is 18 and 3 zeros. Move that. So 100, negative 180. This time together, negative 180. Add 600. 600 minus 180, get 420. So the and put the units is dollar per unit. So this one, we say the actual revenue to be realized from the sale of the 3,000 first Acrosonic Model F loudspeaker system is approximately $420. That's the revenue per unit at 3,000 first. And then next one, find out the profit function. What is a profit function? Profit function is revenue minus cost. The money you bring in and the subtract the expense is net profit, P of x. So P of x is R minus C. So R of x, we figure out R of x is here, P times x. R of x is negative 0.03 x squared plus 600x minus C of x, cost. Cost, we put the parentheses here. Cost is given in the question. C of x is 200x plus 300,000. So plug it in. So here, put it in here. So this is revenue, this cost, subtraction. Remove the parentheses, plus change to minus, combine like term. So negative 0.03 x squared. The two term combined, 600 minus 200 is 400x. And this minus, bring down. So this is a profit function. Add, find out marginal profit function, which is f prime. First derivative of profit function is a marginal profit function. So you do f prime of x. So it's a negative 0.3 times 2 is a negative 0.06 x. 2 minus 1 is x to the power 1 plus 400x take to the 400. Constant term take to the 0. So you got this is marginal profit function P prime of x. Then next, ask you at $3,000, 3,000 units. X equals 3,000. Plug it in. So P prime of 3,000. Plug it in. So get negative 0.06 times 3,000 plus 400. So the two times together is negative 100 plus 400. And they got $220 per unit. So what this means, the actual profit, net profit to be realized from the sale of the 3,000 first Acrosonic Model F loudspeaker system is approximately $220. Then next, we talk about some formulas. Demand function. This is also like this example. P equal. This is a P price, right, in terms of X. This is a P and X. Now here we talk about X, right, in terms of P. If you solve this one for the X, you can write X in terms of P. And you can write X equal in terms of P. So now demand function X is how many units, number of quantity demanded in units. P is unit price in dollars. So demand function X, right, in terms of P, we write down function is X equal F of P. Now, percentage rate of the change of F is change divided by total. FRP is total how many units. And the FRP is change of the units per price. Per $1 price. X equal FRP. So if the price is P dollar, then how many units? We demanded how many units in market, demanded how many units. Now, what is dx dp, which is dp, which is FRP? This take derivative and abbreviate right is F prime RP. What is F prime RP? Is the units is how many units per $1 per $1 change. Denominator is price. Price change $1 per $1 change. Then the units will change how many units. That's F prime of T. And then that's what we call per rate of the change of F. This is called rate of change of F. Function is F prime of P. Now, what is a percentage rate, relative rate of the change, which is divided by total how many units? F of P is X. X equal this is how many units. Total how many units at the price P. At the price P, the per unit, per dollar change will change so many units. You divide it. That's what we call relative rate of the change of the units. If you change to percentage, you times by 100 and divide it by 100. Percent is 100 over 100. This is a percent, which is you times by 100%. F prime RP over FRP. If you times 100%, it is still F prime RP over FRP. This we call relative rate of the change. Relative rate of the change of F functions divided by FRP. That's what we call relative rate of the change. And now you go to times by 100%, which is 1. This 100% is 1. It's still equal. And then you do this times with this. You got percentage. You do 100 times this F prime RP over FRP and put the percent. And this. So then this we call percentage rate. This become percentage rate of change. This we call relative rate. This we call percentage rate. We use change to percentage. We call percentage rate of the change. And they are equal. This one is represented by percentage. So percentage rate of the change is the same as relative rate of the change. So relative change in quantity is is FRP. FRP is X, is quantity, how many units. And then F prime RP is per dollar, how many units changed, divided by X, quantities, how many units. This we call relative rate of the change. And put the percentage, we call percentage rate of the change. Relative change rate is equal percentage rate of the change, equal. So I directly use this. Divided by percentage rate of change, RP. Now P dollar, you can say P is a function. You take derivative RP to dP. Take derivative RP which is just one. P take derivative to the P is just one. It's just like